Hello, and welcome to today's video of electrical materials, where today we will be covering permittivity. First, we can go ahead and define a capacitor, which stores charge and maintains a potential proportion to charge-on terms. A capacitor is made up of two conductive plates, where our top plate is made up of positive charge and our bottom plate is made up of negative charge. We can then define dielectric material, which allows for energy spacing between the conductive plates of a capacitor. Knowing that our dielectric material sits between the two conductive plates of the capacitor, we can define this to be distance d. We can also define the cross-sectional area of the conductive plates to be variable a. All of this relates to permittivity since it is the ability to store energy. We can further see the relation between capacitance and permittivity in the formula. Let's go ahead and wipe the board to further understand the relation between permittivity and capacitance. So for our formula, capacitance, which is denoted as variable C, is equal to epsilon times A divided by D, where epsilon is our permittivity of the material, which can also be defined as the relative permittivity times the permittivity of free space. For A, we have our cross-sectional area of the plates as previously shown, and D, which is our distance between the plates, also previously shown. For permittivity of free space, which is epsilon naught, it is equal to 8.85 times 10 to the negative 12th power in farads divided by meters. Now that we know the relation between permittivity and capacitance, let's go ahead and wipe the board to solve an example. For our example, we have a capacitor has a plate area of 8 meters squared and is separated by a distance of 3.5 meters. If the relative permittivity of the dielectric material is 10, what is the capacitance? So let's go ahead and first start off by noting our given information. We have our cross-sectional area A is equal to 8 meters squared. Our distance D is equal to 3.5 meters. Our relative permittivity, denoted as epsilon R, is given to be equal to 10. And there is no units for relative permittivity since it is a ratio. So now that we know our variables, we can go ahead and set up our formula. You can write that capacitance C, which is equal to epsilon, but in this case we have to solve for epsilon by multiplying our relative permittivity by the permittivity of our free space. So we have 10 times 8.85 times 10 to negative 12, which is in farads over meters. Multiply this by our area, which is 8 meters squared, and divide this all over by 3.5 meters. So now that we set up our equation, let's go ahead and move up the board to continue to solve. So now that we've set up our equation, we can go ahead and multiply our relative permittivity and our initial permittivity. And so after multiplying, we're left with 8.85 times 10 to the negative 11 farads over meters. And once again, multiplying times 8 and dividing by 3.5. And so now that we have solved for our permittivity, we can multiply that by our area. And when we do so, we have 7.08 times 10 to the negative 10th power in farads times meters. And this is because our meter cancels out once. And so now we only just need to divide by 3.5 meters. So let's go ahead and move up the board to continue to solve. So once we divide 7.08 times 10 to the negative 10th power by 3.5, we're left with 2.023 times 10 to the negative 10 power in farads, and this is because our meters canceled out completely. This concludes our video on electrical permittivity. Thank you for watching.